So today we get to start Pythagorean theorem, and we're also looking at its converse. So remember, the converse is when we switch the parts after the if and the then. So let's go ahead and take a look at what the Pythagorean theorem actually says. So it says in a right triangle, and that is major in this problem. So it has to be a right triangle. We cannot use Pythagorean theorem if it's not a right triangle. So in a right triangle, the sum of the squares of the measures of the legs equals the square of the measure of the hypotenuse. So in sense, what that means looking at the picture, a squared plus b squared is equal to c squared. Now remember, c, which is the hypotenuse, is always the longest side of our triangle. So thinking back to what we did on Thursday and Friday last week, if C is my largest angle, the side opposite C is my biggest side. Right, so two things, I already went over this. Pythagorean theorem can only be used for right triangles, and the side opposite the right angle is the longest side. So our first example is just asking us to find one of the three sides of this triangle. So this is our basic Pythagorean theorem that we've actually been using all year long so far. So if we have a squared plus b squared is equal to c squared, C has to be 6. It doesn't matter what you call A, what you call B. So I'm going to do A is 3, so 3 squared plus D squared is equal to 6 squared. So 9 plus D squared is equal to 36. Subtract 9 from both sides, so we get D squared is equal to 27. And then we have to take the square root of 27. So that's not a whole number, so you can either leave it as D is equal to the square root of 27, or we can say that is approximately 5.2 centimeters. All right, so take a moment, try the your turn. So you can pause the video, work on the your turn, and then come back and see how I went over it. All right, so for the your turn, we have to find x. So 15 is our c. So we have 8 squared plus x squared equals 15 squared. So 64 plus x squared is equal to 225. Subtract 64 from both sides, we get 161. So x is equal to the square root of 161, which is approximately 12.7 centimeters. Right, so if you did not get that one right, just go back, try to find your mistake, see where you went wrong before you move on to the next part. All right, so the converse of the Pythagorean theorem. Before we said if it's a right triangle, then we know that a squared plus b squared is equal to c squared. So the converse is saying the opposite. It's saying, hey, I may not know if the triangle is a right triangle, but if I do a squared plus b squared and it is equal to c squared, then I can say that triangle is a right triangle. So for our second example, it's giving us the measures of 3 sides, so 3 different lengths, and we have to decide if it's a right triangle or not. So we have to do a squared plus b squared is equal to c squared. So remember, c has to be the largest value, and 14 is my largest value. So 10 squared plus 12 squared is equal to, with a question mark above it because we are not quite sure, to 14 squared. So I get 100 plus 144, is that equal to 196? And 244 is not equal to 196. So all we know is this is not a right triangle. Let's take a look at the next one. So we have 25 is our largest side, so we have 7 squared plus 24 squared, and that is equal to 25 squared. So we get 49 plus 576 is equal to 625. So if we add 49 and 576, we get 625, which is equal to 625. So that is a true statement. So we know that this is a right triangle. So we can say, yes, it's a right triangle. Done. All right, and now I know you're all going to be super excited about the next example. They put a triangle on the coordinate plane. How exciting is that? So they want to know if this is a right triangle. we are not permitted to get our protractors out and measure it. We have to use algebra to try to figure this out. So what we have to do is find the length of each side. So you could use distance formula to find the length, or since we have the diagram, we can use Pythagorean theorem to help us get there a little bit faster. So we have to find the length of each side, substitute it into the Pythagorean theorem to see if it, in fact, is a right triangle. So I am going to speed this up a little bit. We are going to do RS. So if we do RS, I said RS, but your picture has A, B, and C in it. All right, so now let me get back. So R, A, B, and C. So if we do AB, let's do that one first. I'll show you here on this one. We have to make our right triangle. It's 2 units up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units across. So that makes it pretty easy. I'm pretty sure it's 9 though. 1, 2, 3. Okay, 10 units across. We get 2 squared plus 10 squared is equal to C squared. So we get 4 plus 100 is equal to C squared. So C is equal to the square root of 104. And we can leave it that way. That's fine. We will do the same thing for B to C. And once you go through all of that work, you find out that B to C is the square root of 52. And if you do A to C, you should also get the square root of 52. Now that is if I counted correctly. So when we go through and do all of that work, we have our 3 sides now. So we need to take our 2 smallest sides. So the square root of 52, square it, plus, because remember we're doing A squared plus B squared equals C squared. B would also be the square root of 52 squared, and that is equal to C, which is my longest side, so the square root of 104 squared. Now since we are squaring each one, that means all of our radicals go away. So all of our radicals go away. So I get 52 plus 52 is equal to 104. We'll just go with the black ink. So 52 plus 52 is 104, and 104 is equal to 104. So this is a right triangle. So we can say yes, right triangle, which is good because they asked us to verify it. So that means they were expecting it to be a right triangle. All right, so take a few moments, try the your turn, pause the video, see if you agree. All right, so now that you're back, I'm going to go through this. RS should be approximately the square root of 50. S to T should be the square root of 82. And T to R should be the square root of 32. So that makes S to T my longest side. So that means that's going to be C. So we have the square root of 50 squared plus the square root of 32 squared equal to the square root of 82 squared. So we get 50 plus 32 is equal to 82, and guess what? 82 is equal to 82. So we know, yes, it's a right triangle. Great job so far. So we have one more thing to go over. So we've gone over how to find the side of a triangle using Pythagorean theorem, how to determine if a triangle is a right triangle, but what if it turns out that it's not a right triangle? We can actually use Pythagorean theorem to determine if it's going to be an obtuse triangle or an acute triangle. So if the square of the longest side, so if C squared is greater than the sum of the squares of the other 2 sides, then we know it is obtuse. However, if the square of the longest side, so again, if C squared is less than the sum of A squared plus B squared, then we know the triangle is acute. So our last example says if we're given a triangle with sides 5 centimeters, 7 centimeters, and 9 centimeters, we have to determine if it's acute, right, or obtuse. So we said if c squared was bigger than a squared plus b squared, it is obtuse. And then we said if c squared is less than a squared plus b squared, that means it is acute. So I write that up there because I know a lot of times we do a squared plus b squared equals c squared. But the way those last two pieces were worded, that c squared was first. So our longest side is 9. So we're going to do 9 squared. Is that greater than 5 squared plus 7 squared? So we get 81 is greater than 25 plus 49. 25 plus 49 is 74. And is 81 bigger than 74? It sure is, so that means we have an obtuse triangle. All right, so again, you go ahead and pause the video, try the last your turn, and come back here and see if you get it right. All right, so the last one, 5, 4, and 6 centimeters. So we will have 6 squared. Is that greater than 4 squared plus 5 squared? If it's greater than, it will be obtuse. If it is less than, it will be acute. So we get 36. And you know what? I'm just going to leave a blank box there because we are not quite sure. 16 plus 25. So we have 36. 16 plus 25 is 41. So actually c squared is less than a squared plus b squared. So if c squared is less than it, we get an acute triangle. All right, so that's all for the notes. Now it's time for you to go ahead and do your practice work.